Hello, scholars. Me and my sock hands are back for our lesson today. I know yesterday's video was a little on the longer side when we reviewed all those strategies. Promise you today will be shorter. Just got to make sure we remembered all those strategies. Sorry, with my sock hands, it's kind of hard to move my hair out of the way. Alrighty, my friends, let's get started for today. So obviously you've already clicked into the lesson 8 practice because don't know how you would have found this video if you didn't. So we'll click into here. Reminder to type your first name. If this was Buffy, because she's again the star as per usual of our Google form. Really hard to type with socks on your hands, but gotta do it for the Spirit Week, right? And Buffy is a Hadley scholar. So clicking next, we're rocking and rolling. All right. If you've already watched the routine video, which you know will be right here, then you need to guess what the number is. I'm going to enter a number. If you've already watched the video, you'll know what it is. I will enter then a random number in here. Obviously, that's not the answer because I don't know if that's a multiple of 9, but we got to click into this. All right. So today, my friends, we're going to be talking about another strategy we can use to solve not only multiplication, but even division, which we'll get into next week. But these are something that you're very familiar with. They have rows, just showing off my socks. They have columns. What's the word I'm looking for here? Drumroll, please. It is array. If you said array, go ahead. And I would kiss my brain, but that's kind of weird because these socks, while clean, were at some point on my feet. So go ahead and give yourself a little pat on the back. And let's keep cracking. So we're going to talk about arrays today. And we're going to be talking about how we can be using our knowledge about arrays to help us solve multiplication problems. I know that arrays have something called dimensions. They have something called dimensions. Dimensions are the number of rows by, which we know is like the times sign, the number of columns. Remember, rows are the things that your desks were in when we were in school, right? You sat in rows. Columns hold up houses. Remember that difference. So we're going to talk about how we can be using arrays today to help us solve our multiplication problems. So let's rock and roll. The first question asks us to make a rectangular array of squares to help find the product of 2 times 3. As I get my dot cam set up, because I know you guys are rock stars and you already have your work paper set up, go ahead and try to sketch that out for me right now. Draw me an array that helps us find the product, which we know is an answer to a multiplication question, of 2 times 3. 2 groups of 3 is how a good mathematician would read that. Get cracking. All right, I'm getting my dot cam up. I'm sure you guys have already drawn your array. Here is my dot cam. You have about 10 more seconds before I go ahead and try to draw this array for you guys to give it your best shot to draw the array to represent 2 times 3, or 2 groups of 3. You get to see my sock hands up close and personal. I don't recommend trying this, but like anything for Spirit Day, right? So today's April 8th. Date at the top. I'm sure you guys already are rocking it. All right, get ready. So I happen to have graph paper, which makes drawing an array a little bit easier, but I know that you guys can still rock and roll even if you don't have graph paper at home. No big deal. So I know that I'm doing 2 times 3. If you didn't write that number sentence when you try to draw the array yourself, write it really quick on top. Ready? 3, 2, 1. Thumbs up if you've, or in my case, you can't see my thumb, but thumbs up if you have 2 times 3. Nice. So we know that this, the first number, is the number of rows. Go ahead and label it like that too. And we know that this is the number of columns. Go ahead and make your paper look like my paper. Great. So let's draw an array to help us solve this problem. So I know if I need 2 rows, I'm going to go 1, 2. If I need 3 columns, I'm going to go 1, 2, 3. And then I'm going to close my array. If you don't have graph paper, no big deal. What I would like you to do is just try your best to draw an array and make the lengths about what they would equal, but just be really careful with your labeling here, right? So I know that this has 2 rows, so I'm going to put a 2 on the outside and 3 columns. So I'm going to put a 3 on top. That shows me I have 2 rows and 3 columns. If I had another arm, I could put up 3, but alas, only 2. Now, the way arrays can help us solve our multiplication problems is we can more easily count. You could count every single square, but there's a quicker way. We can, drumroll please, skip count, which is just like we were talking about yesterday, right? This is just another way for us to practice our skip counting to support our multiplication. So you could skip count this multiple ways. You could skip count it by the number of rows or by the columns. So if I look at let's do columns first. If I look at my columns, I see I have 1, 2, 3 columns, and I know that I have 2 tiles in each column, right? I see 1, 2 tiles in each column. So I can count this like this. 2, 4, 6. So I know, even if I counted by ones, I could see that 1, 2, 3, 4, 5, 6 squares inside, right? So I know that 2 times 3 equals 6. Now, another way I could count this even is I could draw another way really quickly, showing you that you don't necessarily need graph paper to do it. So if I know that this is a 2 by 3, 2 rows by 3 columns, I can also count it by 3s, right? I have 1, 2, 3 in this row, and then I have another 3 in my second row, so I can actually do it like this. 3, 4, 5, 6. I can count by 3s. 3, 6. 2 rows of 3 will be 6. Let's see if I can zoom in for you guys there. Great, so that's how we can be using arrays to help us solve some of our multiplication questions. So let's see what this question actually asks us to do. It says, after we draw a rectangular array to find the product of 2 times 3, which we know is 6, which we can also double check by counting 2, 4, 6. You guys can't see my 3 fingers, but they're there. Now let's find the correct combination of rows and columns below. So I'm going to go ahead and click this. We've practiced our drop downs from Eliminate, but just thought I would get some more practice in. So it's asking me, okay, I need to find the correct amount of rows and the correct amount of columns. So I know it should have 2 rows and 3 columns. I'm going to look at my answer choices. I see the first option, 2 rows, 3 columns. Check, but I'm going to double check my other answers just to be sure. 6 rows and 1 column. Same number of tiles, right? But not the correct array to solve 2 times 3. 3 columns and 2 rows. Oh, they're trying to trick me there by inversing my numbers. That would give me a congruent array, but not the one I'm looking for. So let's go ahead and click that. All right, number 2, it tells me to draw an array to solve 5 times 7. Then I need to type the product of 5 times 7 in the space below. So I know product is just a fancy word for multiplication answer. So let's see how we can draw an array to solve 5 times 7. I know, I'm going to separate out my work. I know that that means 5 times 7. That means there's 5 rows and 7 columns. So since I have graph paper, I can count. If you don't have graph paper, or if you maybe can't print some off, not a big deal. Like I said, we can just do our best to approximate, which means we're trying to be precise, but it's no big deal. It's not perfect. So I can go 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. So if you're someone who doesn't have graph paper, I would just draw a rectangle where the side lengths are a little bit shorter than the top and bottom lengths, and then just label the sides. 5 times 7. So let's count by our columns for this one, because I know counting by 5s is a little easier than counting by 7s. So what I'm going to do, and this works really great if you don't have graph paper as well, just draw 7 columns and try to make them as even as you possibly can. Understandably, if you don't have graph paper, even look, me with graph paper, I made some mistakes, but no big deal. So I know I have 1, 2, 3, 4, 5, 6, 7 columns, and I know within each column there are 5 squares. So I'm going to skip count by 5s at the bottom. 5, 10, 15, 20, 25, 30, 35. So now I know that 5 times 7 equals 35. Now, Another way to do this, if maybe you're not as comfortable skip counting, I'll demonstrate with my sevens, because skip counting by sevens can be a little bit tricky. So if I was going to skip count by my sevens, which I'm going to do in pencil, so that means I'm going to be skip counting by my rows, right? So over here, it would be 7, because I would go 1, 2, 3, 4, 5, 6, 7. Even if you don't have graph paper, you can still do this by doing this. So I know I have 7. Then what I can do is go 8, 9, 10, 11, 12, 13, 14, which you can also do on your fingers. I'm going to have to take my fun socks off so you can see me skip count on my fingers. Sorry, I'll put them back on, I promise. So I know if every row needs to have 7 in it, right? Like here's one row, it has 1, 2, 3, 4, 5, 6, 7. What I can then do is, if I don't have my squares to count, if I need support with my skip counting, I can use my hands. And I can go 7, 8, 9, 10, 11, 12, 13, 14. So I have 7 fingers up. So I know that the second row would end in 14, 15, 16, 17, 18, 19, 20, 21, 7 fingers. So I know this row would end in 21, 22, 23, 24, 25, 26, 27, 28, 7 fingers. So 28 would be here. And if I did this right, I should end on 35. Let's see. 29, 30, 31, 32, 33, 34, 35. 7 fingers up. I did get 35. So even doing it both ways, counting by my rows or my columns, even though I was a little tricked, Buffy even agrees, she's coming up, you just saw your ears pop up. I know that 5 times 7 equals 35. So we can still be using arrays to help us support our knowledge. Buffy's going to apparently come over and perhaps check our work. So we know that 5 times 7, she's really checking our work here. Buff, what are you doing, friend? We now know that 5 times 7 equals 35. We can be using our arrays to support our thinking. So let's go do this next one. Select all the expressions that match this array. Now I know arrays, we can represent them by their dimensions, so their length by their width, so something that looks like a multiplication sign in the middle, but also they can be represented as repeated addition, which we know is something that we can use to solve multiplication. Yesterday, I challenged you guys not to use repeated addition as a strategy to solve, but I still want to make sure we're practicing that repeated addition skill and recognizing that we can use it when we are solving the total of our arrays. So what are the various expressions that match this array here? I'm going to give you about a minute to try this problem by yourself. So that means you're in here and you are clicking the options that you think. I know that good scholars are already noting the fact that select all means there's going to be more than one answer. So I want you to quick write select all equals more than one answer, just to remind yourself of that. And I'm going to go ahead and give you a minute to try to solve this. Ready, go. Set it on my watch. You have about 30 seconds left thinking, what are the various expressions that match this array? About 15 more seconds. 5, 4, 3, 2, and 1. Here's what I hope happened in your brain. So the way that I'm talking right now is the thinking that should happen in your brain, hopefully in the past minute. So I'm thinking that first answer choice, 5 by 5, 5 times 5, that must mean that there are 5 rows and 5 columns. So what I'm going to do is I'm going to count, which you can't really see me counting on your screen, but pretend, well, I guess you can. So I'm going to count on my screen, obviously not using the writing end of my utensil, but I would just count 1, 2, 3, 4, 5 rows. Okay, so there are 5 rows. 1, 2, 3, 4, 5 columns. So that first answer choice, I'm going to call it A, even though it's a checkbox. 5 times 5, that works because there are 5 rows and 5 columns. So I'm going to circle that. I know it's an answer choice, but I am not done yet. Say no way. Yeah, select all means more than one. So B, 5 plus 5. Could I use 5 plus 5 to find how many squares are in that array? I really hope that you're shaking your head no and you thought no as well. Because 5 plus 5, that means there's only 2 groups of 5. Are there 2 groups of 5 in that array? No, right? We already know there's more than 2 groups of 5. We know there's 5 rows with 5 in each row. Now, so there are not 2 groups of 5. So I'm going to go ahead and mark that as wrong. I'm not going to choose it. Kick it off the answer island. All right, let's look at this next answer choice. C. I see 5 plus 5 plus 5 plus 5 plus 5. Good mathematician, I'm going to count how many groups that are. That's 1, 2, 3, 4, 5. There's 5 groups of 5 represented in that addition number sense, right? I see 5 times. So that means I know that that does represent this array, right? Because I see 1 group of 5. I just realized I could be using my mouse. Silly Miss Cuppernall. I see 1 group of 5 here, 2 groups of 5 here, 3 groups of 5 here, 4 groups of 5 here, 5 groups of 5, right? 1, 2, 3, 4, 5. This is a 5 by 1, 2, 3, 4, 5. 5 by 5. So absolutely there are 5 groups of 5. I can use that addition number sentence to solve, right? Because it would be 5, 10, 15, 20, 25. That's 5 groups of 5. So absolutely, I'm going to go ahead and give that a check and circle it so I know that I would click that on my answer choice. And then D, what does D have for us? 5 plus 5 plus 5. Are there 3 groups of 5 in this array? I hope you're probably like, no, Miss Cupp, I know there's not. No, we just talked about how there's 5 groups of 5. 1, 2, 3, 4, 5, so on and so forth. So of course there's not 3 groups of 5. We can kick that off of answer island. So your 2 correct answer choices in this case were this and this, A and C. Now let's come on over to D, D, Miss Cupp. I ran out of room on my paper. Buffy is demonstrating that by apparently deciding to sit on my paper right now. Silly cat. So I'm just going to come over to the top. This Buffinator, she just really wants to be in this video tonight, my guys. So let's look at this next answer, or this next question. Draw an array with 32 tiles. What were the dimensions of your array? So in this case, I'm giving you the total amount of tiles, and it's up to you to design what your array will look like. It's really similar to ArrayJar, one of my favorite games. So I'm going to give you about, I'm going to say like 2 minutes, 3 minutes. Come up with any array that you think will result in 32 tiles. Make sure you mark the dimensions on the side, so how many rows and how many columns, so that you can prove to me with a number sentence, a multiplication number sentence, of course, that your array is correct. If you finish with extra time, go ahead and try another one. See if there's multiple ones. Alrighty, so I'm going to queue up that 3-minute timer to draw your array with 32 tiles. I do challenge you to come up with 2 different arrays. All right, here's your timer. See if you can beat me on how many I come up with. If you tried a value and it didn't quite work out, no big deal. You probably just heard me cross something out. Try another one. About 30 more seconds, just under. Five, four, three, two, and one. Excellent job, my friends. Let's see what you've got. See my face again. Alrighty. Okay, so in that time, I came up with two different arrays. So the first way that I solved this, and maybe you did something similar, maybe you did something different. There are more than two correct answers, no worries. So the first thing that I thought about was, and I stole this strategy from actually some of my friends from Hadley, because when we were working in our array jar and when we were working with arrays, they told me that, Miss Cupp, I realized that an even number means I can probably always count by twos to get it, because I know an even number always has a partner. So I always know I can count by twos to reach it. So while I could count by ones and make like a 32 row with a one column, really, really thin and narrow that stretched on like for a super long time, like something that looks like this maybe, that would go like 32 rows down in one column. Or congruently, if we rotated it, or in this case, if I rotated it and made this a 1 by 32 by flipping the dimensions, I know they'll be the same amount, but they'll be, the dimensions are different because the rows and columns switch. But they were like, Miss Cupp, I could do that, but I'm thinking like a mathematician and realizing I can count by twos. So I copied their strategy because I remembered it. And what I did was I just counted by twos until I got to 32. And I kind of just like skipped a line each time. If you don't have graph paper, you can still do that just by stacking the numbers on top of each other. So I did 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32. And I knew that it was too wide because I was counting by a value of 2 tiles each time. But then my job was to figure out how many rows I had. So what I did was I just counted down. So I knew that this was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So I had to count by twos 16 times to get 32 tiles. 16 times 2 equals 32. Now I thought, okay, cool, 2 worked. Maybe 3 will, right? Like I know there's lots of multiples of 3 and 30. So I started the same strategy. I started counting by threes and I counted all the way. But the thing was, I skipped 32. I got to 30, 33. But no big deal. That's how mathematicians, we learn, right? So it turns out I can't break 32. A factor of 32 isn't 3. So I just crossed it out and I moved on. And I was like, if 2 worked, maybe 4 will work. So same strategy. I put 4 across the top. I do something that was approximately 4 squares wide. And I counted by fours. And I went 4, 8, 12, 16, 20, 24, 28, 32. And something that I actually did, because like once I usually get to around 24, I get a little bit tricked, was I thought in my head, 24, 25, 26, 27, 28. And then I wrote 28 like we did yesterday. 29, 30, 31, 32. And I did get 32. Same thing, because I knew the dimension was 4 across. I was counting by 4s, and I had to count by 4, 1, 2, 3, 4, 5, 6, 7, 8 times. So I knew I had 8 rows. So now I also know that 4 times 8 equals 32. Now, thumbs up if you had these same factors, which we know are just the numbers that we multiply together. If you had these same factors, but they were in different order. So maybe your arrays kind of looked something like this. So all of these arrays, right? Buffy apparently agrees. All of these arrays have the same amount of tiles. So mathematicians, right? Buffy is my pen. Mathematicians, Buffy even knows. What do they call them, Buffy? Mathematicians call those arrays. Sounds like the word equal. Whisper it a little louder. I hope you whispered equivalent. If you did, drum roll please, you're a superstar. Yeah, these are all equivalent because they are all made up of 32 tiles. They're like the same amount. They're not like the same amount, they are the same amount. So these are all equivalent. But by rotating my arrays so that I'm flipping the dimensions, I'm making congruent arrays. I'm making congruent. Congruent means they are equivalent. They have the same amount of tiles, but the factors or the dimensions are flipped. Yeah, they're flipped. So that means the congruent array to say 4 by 8, I would flip my factors into 8 by 4, which I am actually recognizing, silly Miss Cupp, we all make mistakes, right? Is this array 4 by 8? Does it have 4 rows and 8 columns? No. This array is actually an 8 by 4. Miss Cup is showing you that everybody makes mistakes. That's how our brain grows. So that array, this array is actually 8 by 4. We have 8 rows and 4 columns. And the congruent array would be 4 rows by 8 columns. I'm actually kind of glad I made that mistake because it makes my point for me, right? If I go 1, 2, 3, 4 rows right here of 8, 1, 2, 3, 4, 5, 6, 7, 8. Ooh, lucky I just got the edge there. Remember, if you don't have graph paper, you can just approximate and then label really carefully. If I know I have a 4 by 8 here, that means I can go 8, 9, 10, 11, 12, 13, 14, 15, 16. I just counted 8 fingers. You can't see them because they're in my socks. Then I can count again. If you have graph paper, you can use your squares. If not, just count on your fingers. 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32. And it works out. Yeah. So my congruent, when I flip the factors, also works. Any of the dimensions that you typed or that you wrote, you can type in here. So in this case, we did 16 by 2. We did a 32 rows, lot by 1 column. We did a 4 by 8, and we did an 8 by 4. Awesome possum. The final question before I'm going to break you guys loose into your independent practice. We kind of went over this. What do mathematicians call arrays that have the same number of tiles? Just the same number of tiles. 30 seconds to pick your answer. What do mathematicians call arrays with the same number of tiles? Okay. Click an answer. Make your choice. 8, 7, 6, 5, 4, 3, 2, and 1. Let's do some process of elimination. The same number of tiles, mathematicians don't call it the same. They use fancy words. Similar? I think they have a more precise words. Congruent. Okay, Miss Cup just talked about that, but I know congruent means there's the same amount of tiles between 2 rectangles or 2 arrays, but the factors are flipped. Those are the ones like an 8 by 4 or a 4 by 8, where if I flip them, I get the opposite, or I get the same ones. But I have to flip the factors, and that question said nothing about flipping factors. I'm going to cross out congruent, which leaves me with the word, drumroll, equivalent. I know equivalent. It sounds really similar to equal. It's what mathematicians call arrays that have the same amount of tiles. Maybe they look different. Maybe they have different rows and columns, but they still have the same amount of tiles. So the correct answer there is equivalent. All right, my darlings, I'm going to clear my screen because it is your time to shine. You're now going to click next and you're going to get cracking on that independent practice. The independent practice looks super similar to what we just did. So use your notes from here. And as always, if you have more questions, go to office hours with Ms. Hendricks or Mr. Cody. Today we worked on using arrays to solve multiplication answers and to find their products. We know the word product, the word product is just the answer to a multiplication equation. So happy solving, my friends. Use those arrays. I'll see you tomorrow.